Hello, and here's our next example in working optimization problems from section 4.7 of our calculus text. This is actually exercise 31 from the textbook. We've got a poster that's going to have 6,000 square centimeters of area, but we're insisting that there be margins all around, and top and bottom margins are going to be 10 centimeters. The two side margins are going to be 6 centimeters. And our goal is to figure out what size should the poster be in order to maximize the amount of area that contains the print. So when I look at this, I see find dimensions that maximize printed area. That tells me what my task is going to be. And so my goal is to maximize the area A that contains print. And so let's draw a decent sketch of what it is that we're looking for here. I've got a rectangular poster. And I've got these margins all around it. And what I'm told is that this margin is to be 10 centimeters, as is this one. And then I've got 6 centimeters side to side. So we want to keep that in mind. Let me make those 6s a little bit bigger. And so I've got my goal. I want to try to maximize A. I've got a passable sketch. And now I need to think about what other variables I have on hand. There are a couple of ways we could approach this problem. And one is to let other variables be the dimensions of the printed area. But I think it's a little bit easier to solve this problem letting the dimensions be letting the other variables be the dimensions of the actual poster, not the printed area. And so I'm going to let X be the width of the poster, and I'm going to let Y be the height of the poster. So this is going to be X right here, and this is going to be Y. So before we go any further, though, let's think about what are the width and height of the printed area. However, I'll use a different color for this. So the question is, how much is this? Well, we know that if I take this amount and add it to what I've got a question mark to, I know that that has to equal X. So I've got the question mark plus 2 times 6 has to equal X. So the question mark is going to be X minus 12. And similarly, if I want to know what's the height of the printed area, I know that the question mark plus 2 times 10 has to equal Y. And so this question mark is going to be Y minus 20. And so what I get to conclude is that X minus 12 is the width of the printed area, and Y minus 20 is the height of the printed area. So my objective equation then is going to be the product of these two dimensions of the printed area. So if A represents the area that's of print, my objective equation is going to be A is equal to x minus 12 times y minus 20. So what's my constraint? Well, let's go here. Our constraint is that the poster has area, the total poster has area 6,000 square centimeters. And so my constraint is that x times y is equal to 6,000. So if I want to put the objective function in one variable, I solve the constraint for one of the two variables. I'll solve it for y. And so y is going to be 6,000 over x. And so I get that my objective in one variable is x minus 12 times 6,000 over x minus 20. And I'll expand that out in just a minute before we calculate a derivative rather than using the product rule. But first I want to think about the domain. So in order to figure out what the values of x are that make this possible, we need to remember that both dimensions must be at least 0. So that means that x minus 12 is bigger than or equal to 0, and 6,000 over x minus 20 is bigger than or equal to 0. So these two dimensions both have to be 0 or bigger. Well, here that's pretty simple. X has to be bigger than or equal to 12. This one's a little bit more complicated. And then I get 6,000 is greater than equal to 20x, and so x is going to be less than or equal to 300. And so my domain for x is everything between 12 and 300 centimeters. So now let me expand the area formula before we go ahead and calculate the derivative. We could use the product rule here, but it's maybe a little simpler if I just FOIL this out. So x times 6,000 over x is 6,000. 12 times 6,000 is 72,000. And then I get minus 20x, and then plus 240. And so if I combine those two constants, I wind up with 5,760 minus 72,000 over x minus 20x. So here is another version of my objective equation solved for one variable. So I calculate the derivative. So I'm going to get 72,000 over x squared minus 20 if I apply the power rule to calculate the derivative. And so to find the critical number, I set a prime equal to 0. I can add 20. Multiply by x squared. Divide by 20. I'm going to get 3,600 equals x squared, or x equals, it says plus or minus 60, but we know that we need x to be on the range from 12 to 300, and so x equals 60 is my only critical point. Now I need to verify I've got a max. So I've got a function defined on a closed interval, so I can create my table where I look at the endpoints and my critical point. So I'm going to use this formulation for A in calculating my values. And so when A is 12, I'm going to get 0. 6,000 over 12 is 500. 500 minus 20 is 480. I get 0 from that. When x is 60, I get 48. 6,000 over 60 is 100. 100 minus 20 is 80. 48 times 80 is 3,840. And then when x is 300, I'm going to get 288 times 0. And so here is my max value. So the max occurs when x is equal to 60. And if x is equal to 60, that means that y is 6,000 over 60, or 100. So the dimensions of the poster that optimize the amount of printed area are 60 centimeters by 100 centimeters, but we need the dimensions of the printed area. So remember that the printed area is x minus 12 by y minus 20. And so let's try again. So the width of the printed area is 60 minus 12, or 48 centimeters, and the height of the printed area is 100 minus 20, or 80 centimeters. So our answer to our question is the printed area, let's try again, the printed area is maximized when its dimensions are width equals 48 centimeters and height equals 80 centimeters.